Frugal Systems Design is about taking systems that you use in your daily lives and coupling them with other things. For instance, let's say that you make cider. So when you're making cider, you press the apples, or you chop up the apples, press them, and you get the juice and you make the cider. And the chopped up apples basically goes to waste in lots of the systems. So a frugal system, instead of chopping up the apples, you might peel them, core them, and then say dice the apples. And instead of pressing them, they just go straight in with maybe a tiny amount of liquid into your fermenter. And the gas that comes off the fermenter, instead of just letting it just bubble, you let it build up a bit of pressure and you use it to pump water. I have a little thing on the site about a little water pump that I have actually used. It's got no moving parts, and it is powered by the air that comes, or the carbon dioxide that comes out of a fermentation process. So this actually works. And then at the end of your primary fermentation, which might be 7 to 10 days, you would drain off the liquid for the rest of your cider process. And instead of casting out your apples, the diced apples could then be used in a cake. And the advantage of this is flavor is pretty good. Plus, you now have the added protein from the yeast production, and it's perfectly safe to use because back in Europe 200-300 years ago, the children were beer was basically the safest stuff that you could feed children, because if you fed them straight water or milk, they would get tuberculosis from the milk, or typhoid fever from the water. So it's actually an antibacterial process when fermentation, anti the harmful bacteria. And it doesn't have to be brewing to power any type of fermentation powered pump. It can also be just ordinary garden waste in a closed system will ferment and produce gas too. So that's what I mean by a frugal system. It's a larger system where each part might not be so productive as with the the one. Everything is in the modern world, people try and produce the most of one thing, and they kind of forget that there's instead of having a waste material at the end, everything gets used. So that's part of the frugal design process. Another thing is I have a little small solar panel, but I've never figured out how to I have it charging a little battery, and I've never figured out how to discharge a battery without discharging it completely. You turn something on, if you turn on a light connected to the battery, it will drain the battery until the battery won't charge anymore. So you need a little part of your system that will automatically trip when long before the battery gets drained entirely. And so if your battery was set to some system which turns on and off when there's power, then you'll get much more value from your little tiny solar panels, which are basically useless, than if you don't have this automatic tripping in your system. I have considered using the solar panel to sort subsoil, because I have subsoil at my area is very rich in clay, so it could actually be sorted into sand and clay, and the waste material would be silt in this case, which maybe there's a use for. Sand is a building material. Clay could be sold for potting, or it could be used with sand to make cob, which is also a good building material. Incidentally, cob here, there is a house here which is designed to withstand earthquakes. It's engineered cob house. So these old techniques can fit into the modern world too. All we need is systems where the materials are quality tested, and even the small little systems, the Frugal system, little tiny backyard system, could do this. Could be set up to automatically do this. The pictures here are from my low head water power thing. So gravitational vortex, a guy in Austria thought of this, and it's a slow turbine in a vortex, and fish can pass through it far easier than they'd be ground up into fine meat in a fast moving turbine. The thing below it at new mills is a hydrodynamic screw. These were patented in 1992, and it's basically an Archimedes screw working in reverse. So Archimedes screws have been around for well over 2,000 years, and they're used generally hand operated, where a guy stands at the top and turns the screw and pumps up water. And I guess the guys know it's a reversible, it's like a reversible chemical reaction. It's a reversible reaction. If you put water in at the top, it will turn the screw the opposite way as it goes down to the bottom. So people have probably noticed this for thousands of years, but no one used it. And now these turbines are all over Europe on low head sites, and once again they're relatively easier for fish to pass through them than to pass through the typical fast spinning electrical generation turbines. And people have the efficiencies on both these things are pretty high, so it's just something to think of, that we shouldn't be so close-minded about looking at things around us and looking what else is reversible and what else can you use that's small, using small-scale streams to do something useful. And there might be lots of things around us where, if you just open your mind a little, and your fellow people have to have open minds too, can see that there's many more than one way of doing things. There's lots of things, simple things, that haven't been discovered, and these are two things from the last, say, 10-15 years that we should have noticed. Even myself, I've cleaned out grain elevators, or sorry, not grain, the augers for combine harvester, and you would see it that if it's full, to clean a house, it turns on its own until the grain is at the bottom. So we need to look a little more open-minded at all the different processes around us, and some of them can be used to do useful stuff if it's coupled with something else. Yeah, that's it for now, and I'll improve the talk later on.